So let us see some few examples. So we have a equation for a particular standing wave on a string is given by that. So find the amplitude of vibration at antinode. Okay, find the amplitude of the vibration at antinode. So we know that hii imeuliza ya hii vibration ilikuwa ni standing wave, ilikuwa ni stationary wave. So what we want to know is the combined or resultant amplitude. So we know from our equation, tuna general equation ambayo amesha kuandikia hapo. Tunajua for this case Wt imekaa kwenye cos, as you can see. Unatafuta tu t ilipo ujue kule ndo imekaa Wt. Wt imekaa kwenye cos. That means amplitude yetu ni paka hapo. Kwa hiyo unaichukua that part only excluding ile part yenye Wt. So tunajua hapo kwamba our amplitude is 0.15 sin ya 5x. So this being our amplitude, this is the equation of our amplitude. But for this case 2a ndo hii 0.15 na 2 pi over wavelength ndo hii hapa 5. So we have, according to this question, 0.15 okay sin ya 5x, sin ya 5x. But we know stationary wave, okay, tukichora a simple description of stationary wave, we know it's this way, okay, this way. So what we are supposed to know kwenye swali ni kuangalia x, tumeambiwa tutafute amplitude katika point gani along x, because you know superposition principle speaks of amplitude ya sehemu yoyote katika stationary wave. Tunaweza tukatafuta amplitude ya that point, the resultant, okay, for this case we are calling it resultant amplitude, for that case, for that point, for any point along this line. But for this case x yetu tuliopewa au distance au point tuliokuwa allocated tutafutie amplitude ni kwenye antinode. We know antinode ni sehemu ya maximum displacement, so itakuwa ni hapa katikati hapa, okay, itakuwa ni hapa katikati. So we generally know katika sine wave yoyote, this is sine, katika sine wave yoyote the maximum point ya sine ni value ya 1, okay, because the maximum value ambayo unaweza ukaipata kwenye sine ni 1, haiwezi kuzidi hapo, okay. And since point tulioambiwa ni maximum, it means this value ni 1, okay. That's one point of reasoning. That means amplitude inabaki ni 0.15. Ndio maana unaona hapa ameandika 0.15. Other way ambayo unaweza ukaiangalia hii ni kwa kufanya hivi. Okay, we know kwamba kuanzia hapa all the way mpaka hapa ni nusu ya safari. So katika cycle nzima ya 360, this is just 180, okay? So ukimalizia the other cycle ya chini unakuwa umemaliza 360. So we know upper half ni 180 degrees, okay? So at maximum point, this point hapa ni half ya ile half, so ni quarter. If this half was 180, so its half inakuwa ni 90. So the point tulioambiwa sisi ni at point ambayo ni 90 degrees. So if we put x value yetu ni 90 degrees, tukichukua 90 mara 5 tunapata 450. Ukitafuta sin ya 450 unakuja kupata value ni 1. So that's the point I was speaking, kwamba the maximum point ya sin value yake ni 1. So those are two ways of reasoning. So ukiweka hapo sin ya 450 tutaona ni 1. Nimeweka in degrees kwa sababu nataka nitafute sin in degrees. Unaweza ukaamua kuweka kwenye radians kwamba nusu ya safari huwa ni pi radians. Okay, so kwenye antinode ni pi over 2 radians. So if you put pi over 2 radians unakuwa 5 pi over 2 radians. So tafutia sin, calculator yako ikiwa kwenye mode ya radians, still utakuja kupata 1. So jina hapa jibu la amplitude tunabaki 0.15. Ama swali inahitaji tu reasoning na comparison basi. So the distance between the nodes, it means kutoka node moja kwenda node nyingine, ndio wanachotaka hapa, distance between the nodes. So we know that, as I illustrated earlier, that we have our wave equation, okay, stationary wave equation. So we know the nodes ziko at this point, at this point, at this point, etc. So this is at point 0 origin. We have another node at point pi, and we have another node at point 2 pi. Okay, these are the values, the angles ambazo zitatupa nodes. So tukiangalia this point, it means our value, kwa sababu ukiambiwa utafute distance yoyote kwenye equation unaitumia part ambayo ina value ya x. Okay, part yenye value ya x. For this part, for this case, sin 5x ndio ina value yenye x. So speaking of node ya kwanza kwenye origin, remember these are the angles. So the angle of 5x, okay, has to be equal to 0. So x is equal to 0 at the origin. Then tukienda kwenye region ya pi, then 5x lazima iwe sawa na nini? Na pi. Okay, so from here we get x ni sawa na pi over 5. So we will get distance at this point. So kupata distance between the nodes, kupata node E mpaka kwenye node E ni sawa na this 5 pi ni sawa na hii distance minus this distance. So this minus 0 napata pi over 5. So eventually the answer ni pi over 5, ambao pi over 5 as you can see hapa ni 0.628 meters. I hope it's clear. Kama ipo clear, you can repeat that part ili uelewe vizuri, but it's just an issue of comparing na reason. That's the way we do these questions. Kumbuka pia zipo kwenye simple harmonic motion. Part ya kwanza simple harmonic motion ni somehow inajirudia this part, except for this case ya progressive. Yenyewe ya stationary, yenyewe tunakuwa tunatumia progressive wave zaidi. Maswali yanakuwa ulizwa kwenye progressive wave. Otherwise ni issue ya kucompare. So another question is find the wavelength. Okay, so tunaangalia kwenye equation yetu wapi ambapo tulikuwa na wavelength. Our general equation ni hapa, sehemu ambapo tulikuwa na wavelength ni hapa. Okay, so what we do is just compare kwamba we have 2 pi x over wavelength inatakiwa sawa sana kwenye equation yetu tumepewa 5x. Okay, una compare to what does this sign have, inatakiwa sawa sana what this sign have. Okay, kuna kwa 5x. So x na x zina cancel, unabaki na wavelength ni sawa sana 2 pi over 5. 2 pi over 5. So as you can see kwamba wavelength is 2 pi over 5, unapata 1.26. We just reason like that way. So what is the frequency? Where can we get the frequency? Angalau this formula imeifungua further. Kumbuka tunaipata frequency kwenye part yenye WT. Part ambayo ilikuwa na WT ni hii course ya huku. Okay? So we know WT ni sawa na nini? Okay, let us clear this so to get a place to write. Okay? So we know WT is equal to, for this case tumepewa, tuna compare. Okay? Ndo 300 T. Okay? 300 T. So we can cancel the T na T, tunabaki na W. Lakini kumbuka W ni sawa na 2 pi over period. But 1 over period ni frequency. So ni sawa na 2 pi times frequency. 1 over T ni frequency is equal to 300. Okay, is equal to 300. So frequency inakuwa sawa na 300, as you can see, 300 divided by 2 pi. So 300 divided by 2 pi unapata frequency as you can see hapa. Okay, 2 pi f ni hiyo, frequency sawa na 150 over pi ambao ndo 300 over 2 pi. So we get the answer is 47.7 Hz. The last question is to find the speed of the wave. We know that the speed of the wave ni sawa na frequency times the wavelength. You remember kule mwanzo nilisema from the basic concepts of waves, sawa na frequency times wavelength. We have the frequency 47.7, we have the wavelength 1.26, we can combine and get our velocity. So you can try this question, inafanana exactly na the question above. So you can try this on your own and see kama umenielewa. We are doing it exactly the same way tulivyofanya. Only that you should not, sawa, akikwambia they are measured in centimeters and T in seconds. X is measured in centimeters and T in seconds. So you should know that However, you're going to manipulate this equation. Value yako ya x tutapata in centimeters kwa vyovyote vile ambavyo utamanipulate. Sawa, kwa mfano kwa jinsi hivyo kwa tunatafuta x hapa. Sawa, 5x is equal to pi. So jibu letu hapa sisi hapa kwa this case tungepata in centimeters. So be very careful units wanazokupa kwamba hii equation imetumia units gani. So you should be careful. So for instance this part ya x tulipofanya hivi hapa jibu lingekuwa in centimeters kwa sababu umeambiwa x ilikuwa in centimeters. Okay? Yeah, so the same to the wavelength. So the same to the wavelength. Hapa tulipopata 2 pi over 5 the answer could be in centimeters. The answer should have been in centimeters kwa sababu the distance is measured in centimeters for this equation. Okay? So be very careful with the units ambazo unapewa. So another example, unaweza ukapewa sio stationary wave, unaweza ukapewa progressive wave. Okay, as you can see hii ni progressive wave, sio stationary wave, ni progressive wave. So you have 2 points on a progressive wave which differ by phase ya pi over 4. Okay, so you have a progressive wave in a 2 points which differ by phase pi over 4. Phase yangu ambayo ni hapa. Okay, perhaps moja ina 0, nyingine ina pi over 4. The distance between them is 0.5 meters and the frequency of oscillation is 10 hertz. What is the minimum speed of the wave? Okay, so you have the displacement y at distance x and time t of a sound propagating in air can be presented by that. Well, okay, these are two different questions. So to start with this question, we know that progressive wave y is equal to a sine w t plus or minus phase angle ambayo ni 2 pi x over wavelength. Okay, x over wavelength. So we have been told kwamba these two they differ by a phase of pi over 4. May I solve it down here? Okay, these two differ by pi over 4. It means kama moja ina 0, okay, if we have one point with phase angle ya 0, another point itakuwa na phase angle ya pi over 4 in any way, kiasi kwamba ukichukua phase angle ya huyu minus phase angle ya huyu unapata pi over 4. But we know phase angle ni 2 pi, okay, x over wavelength is equal to pi over 4. So if that is the case tunaangalia tu hapa. We know that x is given, the distance between them is 0.5 meters. So we know x is 0.5 meters. This is 0.5 meters. So we can find the wavelength because when we have the wavelength, tuna frequency tunaweza tukatafuta hiyo speed. Okay, so we know from here wavelength itakuwa ni sawa na 2 pi times x ambayo ni 0.5. Okay, divide by, if pi comes down here, pi over just pi, okay, and times 4 huku juu because this 4 goes that side na hii wavelength inaenda huku, pi inashuka chini hapa. So pi na pi zina cancel and you remain with your answer ni 4. Okay, 0.5 times 2 ni 4, ni 2 times 2 ni 4. Okay, so the answer of the wavelength is 4. So we know the velocity ni sawa na frequency times wavelength. So the frequency given is 10, the wavelength given is 4, and we have our minimum speed of 40 meters per second. Okay, yeah, so it is solved like. So another question, the displacement y at distance x and time t of sound propagating in air. The equation umepewa hapo ni progressive wave pure kabisa, where x and y are in meters and t is in seconds. Okay, x and y are in meters and t is in seconds. So remember these are in SI units, both of them. So sketch on the same axis a graph of y against x at time t is equal to 0 and at time t is equal to t over 4. Okay, it means it is quarter of the whole motion, because t in time period in time for the whole complete oscillation. So t over 4, it means ni quarter of the total motion, quarter of the total motion. So generally hili ni swali ambalo linapima uelewa wako, because the first thing you should note ni kwamba this negative sign, it means it is negative, it is on the left, it is moving to the right. Okay, the negative, it is on the left and moving to the right or towards the positive x axis. So how you start to plot ni kwa kuangalia kesi zote mbili. We know if this is our xy plane, if this is our xy plane, at time t is equal to 0, ukiweka t is equal to 0 hapa, inabaki sign ya negative hiyo. Kwa kama ulivyoona hapa 7.5 times 10 power negative 4, sana sign is equal to negative. So according to the principles of sub, this negative can go outside. This makes our amplitude negative. Ndani inabaki sign that. So we want to plot from the origin. So we know that from the origin at time t is equal to 0. Okay, from the origin at time t is equal to 0, our graph goes down because amplitude yake lazima iwe negative. Na kwenye origin, okay, na kwenye origin sine curve huwa ni 0. So kwenye origin sine curve ni 0. We plot our graph, it goes that way. Okay, it goes that way. Lakini at time t is equal to period over 4, it means ni quarter ya motion. So we know katika sine curve yoyote, this is one complete oscillation. So this all from mwanzo mpaka mwisho ni t kubwa, the time period, the whole motion. At this center ni t over 2, ni half of the motion. At half of the half motion ni quarter. Okay, this point ambapo tunakuaga na amplitude, this point ambapo tunakuaga ni amplitude, the distance is wavelength over 4 or period over 4. Okay, ni period over 4, wavelength over 4, whichever way you call it. It means that t is equal to period over 4 inaanza na maximum, ni point ambao kuna maximum amplitude. So yenyewe tutaanzia ku sketch kwenye maximum, and is it positive or negative? So we can check. Okay, tukiweka 2 divided by 4, we can see that our equation generally ndani kutakuwa na a positive number, kwa sababu unapoweka t, kwa mfano hapa you put 315 t divided by 4, okay, minus, remember tunaiplotia kwenye origin, sababu tunataka kuiplotia kuanzia kwenye origin, ni point ambayo x is equal to 0. So this value will cancel, ndani itabaki ni sign ya 315t over 4. Okay, 315t over 4. Hata hapa sawa, hata hapa kwamba kwenye origin x is equal to 0, so x is equal to 0, we have no problem with that, lakini our amplitude imeshatuonesha ilikuwa negative. But for this case, ukiweka x is equal to 0, kwa sababu tunaiplotia kuanzia kwenye origin, x is equal to 0, this cancels, inabaki 3 sin ya 315 times time period, sin ya 315 times time period. So if you check that, inakuwa ni a positive value, so our amplitude remains positive. Sio kama hii ndani inabaki negative, inatoka nje, amplitude inakuwa negative. So we know inaanzia maximum and it is positive, so that way inashuka, just plot it that way, kwa kama walivyo plot hapa, as you can see. So the first thing you have noted ni kwamba lazima uangalie it's negative, so where does it move to? Kama ina move kutoka kwenye left kwenda kwenye right, so everything else progresses from there. Determine the velocity and the frequency of the wave. So you just compare with the general equation. As you can see hapa, amekuandikia general equation ni a sin ya, of course ameifactor out, hii ni sawa sawa tu na ingekuwa ameifactor out ili kukurahisishia, kukuwekea all possible factors. Okay, ni sawa sawa na a sin ya wt minus 2 pi x over wavelength. Okay, it's the same thing na hicho, sababu ukiingizia huko ndani 2 pi f ni wt na hii 2 pi x over wavelength inakuwa ni sawa sawa. So issue from there ni just compare, determine the velocity and the frequency of the wave. So just compare, where can we get the frequency? You can get the frequency from this w. As you remember the previous case, tulisema kwamba 2 pi f ni sawa sana angular velocity. So if we compare if we compare 2 pi f au w, this one, if we compare 2 pi f au w, compare na huku ndo hii hapa 315. So 2 pi f is sana 315. So from here you can get frequency ni 315 divided by 2 pi. Tunapata 50.1 hertz. Just like that. Tunapata frequency. Velocity tunatafuta kwanza wavelength. Wavelength tunaweza kuiona hapa 2 pi x over wavelength, tukicompare ndo hii hapa 1.05 x. Okay, 1.05x. So if you compare x na x zita cancel, utabaki na 2 pi over wavelength ni sawa na sababu x ndio hii hapa x. So 2 pi over wavelength ni sawa na 1.05. 2 pi over wavelength ni sawa na 1.05, then from here tunapata wavelength is that way 5.98. Then we use our wave equation tunapata our velocity. Like that. Calculate the phase angle of a point 2 meters from the origin. Okay, 2 meters from the origin. 2 meters from the origin, we know the phase angle is given by 2 pi x over wavelength. So if x is 2 and the wavelength tumeshapata, so we can get the phase difference. So we have 2 times pi times value ya x ambayo ni 2 divide wavelength ambayo ni 5.98. Okay, wavelength is sawa na 2 the wavelength is 5.98. So if we put in the numbers, we get our answer, which is 2.1 radians. Tunapata in radians kwa sababu ya units tulizotumia. Okay, tumetumia angular velocity ambayo symbol yake ni in radians. So our answer most of the cases inakuwa in radians. Okay, yeah, so as you can see ni 2 times pi. Okay, 2 times pi times value ya x ambayo ni 4. Okay, times value ya x ambayo ni 4 divided by wavelength ambayo ni 5.98. As you can see 5.98 times 2 pi radians times value ya x ambayo umepewa ni 2 meters. So finally ukiingizia unapata 2.1 radians. So we can try this question. You have a transverse wave which is traveling on a string. The displacement of a particle is given by that progressive wave. It is negative, it is on the left, it is going to the right. So while y and x are in meters, t is in seconds. So measurements zetu tukipata velocity inakuwa in meters per second, wavelength meters per second, because the measurements are in SI units. The linear density tumepewa ni 0.5 kg per meter, but we know for the string, principle of physics nimekuwa napiga kelele siku zote nikisema kwamba kama ujipa kuanzia, wewe andika vitu vinavyo relate kulingana na statement ya swali ulizopewa. Kwa mfano hapo umepewa linear density na utafute tension. Unajua relation ambayo inakupa velocity, tension na mass per unit length ni ile ya velocity sana square root ya tension over mass per unit length. So we have mass per unit length, inabidi tutafute tension. It means velocity lazima katika data tulizopewa lazima kuwe kuna namna tunaweza tukapata velocity. Okay? So tunapo evaluate hilo swali kama ujipa kuanzia, this way inakusaidia ni namna ya kufanya. So najua t ndo natafuta, so v lazima statement zilizobaki katika swali ziwe zina namna ya kutafuta v. But we know kwamba our general equation inakuwa ni y is equal to a sin ya wt minus kx. Okay, where k is the wave number or 2 pi over wavelength. So if we compare, we know w ni sawa na 20, so 2 pi f ni sawa na 20. So f ni sawa na 20 over 2 pi. Okay, 2 pi. Tunapata frequency yetu. Also tunaweza tukapata wavelength from here kwamba k ni sawa na 2 pi over wavelength, ambao for that case our k coefficient ya x ilikuwa ni 3. So ilikuwa ni 3. So wavelength inakuwa ni sawa na 2 pi over 3. So we know velocity ni sawa na frequency times wavelength. So we know frequency ni sawa na hii hapa and the wavelength is there, so we can solve for t just like that. So we have a couple of more examples. We have another form of progressive wave which has a frequency of 800 Hz and a speed of that can be stated in the form of the following question as we are given there. Calculate the value of wavelength k. It's very straightforward. Okay, what is the phase difference between points of one distance 1 meter apart along the progressive wave? Very straightforward. So calculate the value of w and compare. Okay, it's not an issue of comparison, it's just somehow calculating. You have the frequency, so you can get 2 pi f, unaweza ukapata w ambao ni 2 pi f. So you have 2, you have pi, you have the frequency given hapo, so you can get your value ambao ni 1600 pi in terms of radians per second. That's the units of w. Find the value of k. Okay, you remember that k ni sawa na 2 pi over wavelength. Okay, k ni sawa na 2 pi over wavelength. If you recall this part, okay, nilikwambia phase angle ni 2 pi x over wavelength, so sometimes they like to refer this as k. Okay, ndio maana utakuta some of the places wameandika kx, so it's not an issue ambao ni new, it's just an issue ambao straightforward. 2 pi over wavelength, you have 2 pi the wavelength you can get kwa sababu kwenye speed una speed na una frequency, so you can get the wavelength from here kwamba speed over frequency is sawa na wavelength, so you can get the wavelength. You can put this as straightforward. Phase difference between 2 points, one, you know the phase difference 2 pi x over wavelength, how is equal to kx. So we have the k which is 14.3 and we have the value of x ambayo tumepewa tuitafutie ni 1 meter, so you can get the answer just like that, the phase difference. Another question, we have a question at transverse wave traveling along a string, given the equation where x and y in centimeters and t in seconds. The units are in centimeters and t is in seconds, so be careful of the units. Calculate the amplitude. We know the amplitude by comparison. Okay, if we compare our general equation, y is equal to a sine ya 0.2x plus 5t. If we compare a, ndo hii hapa 6, so simple, amplitude is equal to 6. As you can see, 6 what? Centimeters, because we remember the distances are measured in centimeters. Calculate the wavelength, we just compare. Oh, I forgot to nimerudia swali baada ya kuandika general equation. So we know we have wt here plus 2 pi x over wavelength. Okay, so tunapoambiwa tafute wavelength tuna compare to x na x. 0.2 is equal to 2 pi over wavelength, so 0.2 is equal to 2 pi over wavelength. As you can see from here tunaweza kupata wavelength ambao ni 2 pi over 0.2 ni 10 pi centimeters. So kwa issue ya frequency tunaweza tukaipata hapa kwa sababu w ni sawa na 2 pi f, so 2 pi f ni sawa na 5. Okay, so 5 ni sawa na 2 pi f, so from here you can get frequency ni sawa na 5 divided by 2 pi, tunapata frequency. The speed again tuna frequency na tuna wavelength, so kwa combine frequency na wavelength ambazo tumepata hapo juu tunapata our speed. Remember all units measuring the distance lazima ziwe in centimeters. Whatever centimeters hapo maana centimeters per second velocity. Direction of propagation, so it is positive, it is on the right, it is going to the left. It is positive, it is right. It is right to be positive, so it is positive, it is right, it is going to the left. It is going to the left, so right to left. We have water waves in Kendana Lake is represented by the equation here, where x in meters, y in seconds, calculate the velocity. So I will leave that so that you can do it on your own. So write the equation which represent the water waves in Teratai Lake. One thing to note, kwenye nectar questions, most of the nectar questions huwa wakitoa swali moja ambao wanapenda sana kuliuliza ni kwamba rewrite this equation, sawa, going in the opposite direction, ambao ni very very simple. You just change the sign. Okay, you just put positive because linataka kukupima if you know what determines the direction in this equation. Okay, what determines the direction. So linakwambia tu rewrite kwanza swala kwanza linauliza where does this the propagation direction of propagation of this progressive wave. So utasema it is negative, it is on the left, it is going to the right. You don't mention, hizo nilikupa techniques za kukumbuka. So just say it is moving from the left to the right. So ukiambiwa rewrite going in the opposite direction, rewrite the equation going in the opposite direction. It means it is now going to the right, to the left. So if it is, you want it to be right, you have to change it to a positive. So it moves from positive to negative. So that's it. You just change the sign and you write this equation with a plus. But this question lingekuwa liko complete, lilikuwa linauliza, so you rewrite this equation, okay, rewrite this equation, but it should be having the same angular velocity. It has the same angular velocity with which the velocity of propagation is twice the initial, okay, is twice that which indicate kwenye swala hapo la part A. So the velocity should be twice. So if the velocity is twice, it changes everything. It changes if the velocity is twice and the amplitude is half. Hilo swali ndio liko linauliza hivyo. Kwa write an equation which represents the water waves at in Teratai Lake which have the same amplitude as above. I mean the same angular velocity as above, half the amplitude and twice the velocity, and it is going in the opposite direction. Okay, so you write an equation. So you know that your equation finally should be positive, as you have seen. Direction should be positive, as it has been shown up, should be positive. And so changes in the velocity changes everything, as you can see. W ilikuwa ni 20, amplitude ikiwa half, it means from 0.6 divided by 2. So inaweza kuuliza namna tofauti kukupima kama unajua where is the amplitude, where is the velocity, as you can see hapo. Kwa kukuambia tu amplitude is half, hajakwambia amplitude iko wapi, so wewe ndio unatakiwa ujue from the equation amplitude ilikuwa ni 0.6. So if it is half ni 0.3. And the velocity ambayo tumepewa initially, this time it is twice. Kama velocity mwanzo tulipata 5 kwenye part A, this time velocity inakuwa 2 times 5 ambayo inakuwa ni 10. Okay, lakini the same new velocity ni sawa na frequency. The frequency remains the same, okay, frequency remains the same, but the amplitude changes, because when you change the velocity you are changing the wavelength, maintaining the frequency of the wave. The frequency of the wave can be maintained, okay, the frequency of the wave can be maintained because we want the same time ambayo the wave was passing should remain the same. So okay, so the frequency remaining constant, the wavelength changes, and we have the new wavelength which is pi meters. So using all the details that we have, tutaitumia kurudi rewrite the equation. You see y is equal to the new amplitude, we have the new angular, we said that it should have the same angular velocity. So having the same angular velocity, ndio maana hata frequency imebaki the same. So the same angular velocity inabaki 20t plus the new direction ambayo ndio imebadilika. So the question required you to write in a different direction, going in opposite direction, with the new values that the phase angle ambayo ni 2 pi divided by pi x. So you can see the phase angle inabaki ni 2x, unlike mwanzo ambayo ilikuwa ni 4x. So that way, just remember, ukiambiwa write in opposite direction, if it was negative inabadilika tunakuwa positive, plus all the other details ambazo watakupa. If it's just an issue of rewriting with all other parameters zikibaki hivyo, just change the sign. Okay, a couple of more examples in which you can solve on your own. You can solve on your own here. You can try this on your own. This is just the same as tulivyopitia nyuma, so you can try on your own. Maybe this can be different. Wave function for a traveling wave is given by that. What, don't worry about this. Hizi ni mbwembwe tu jinsi ya kuandika namna tofauti. Okay, but you just you can just see E ndo WT, then E ndo phase angle yote. Yote ndo phase angle. Yote ni phase angle. So what is the speed and direction of the wave? The speed and direction of the wave, we know that the direction of the wave, it is negative, it's left, it is going to the right. Okay, it is negative to the left, is going to the right. so we can tell them that is going to the right. Remember, negative tunayoangalia ni hii hapa. Kumbuka kuzigroup phase angle, kuigroup pamoja namna hii. Okay, remember kuigroup pamoja namna hiyo, remember that. Okay, ili isikuchanganye, because unaweza kusema this is positive kumbe ni negative huku ukiangalia, so be careful with that. The speed you can just check, but remember ukiambiwa angular velocity, okay, ukiambiwa angular velocity ni tofauti na ukiambiwa speed. There is difference between v na w. Okay, usije ukatafuta speed kwa kutumia w. Ile ni mara nyingi wakikuuliza angular frequency, they might ask you angular frequency, ambao ndio hiyo w wanaotaka kuimaanisha. Wakikuuliza frequency ni ile f, wakikuuliza angular frequency wanamaanisha w. Lakini wakikwambia speed wanataka utafute the value of v, ambao ni sawa na frequency times wavelength. So we know from wt hapo unaweza kupata frequency. Nimesha kuelekeza jinsi ya kupata frequency, so try on your own for compare. Na wavelength unaweza kuipata at this point. Sawa, wavelength unaweza kuipata at this point kwa sababu una compare to 3 pi x plus pi over 4 ni sawa na wavelength ambao ni 2 pi, ni sawa na phase angle ambao ni 2 pi x over wavelength. So you just put in the numbers na unapata wavelength kwa kutumia frequency ambayo ulikuwa nayo, unakuja kumalizia. So kwenye kutafuta wavelength usichanganyikiwe, sawa? Wavelength itabaki tuna compare na the same ambayo tunayo hapo. Tuna 3 pi x, hii ndio tuta compare na kwenye general equation yetu 3 pi x over wavelength. Unaachana na hii, ilikuwa ni phase angle nyingine ambayo ilikuwepo, sawa? It means this time our general equation inakuwa ni a sin ya wt plus 2 pi x over wavelength, 2 pi x over wavelength plus kuna phase angle nyingine ya pi over 4. So tunapokuwa tuna compare this na ile part yake yenye x ambayo ni 3x pi over wavelength, ndio tunakuwa tunaicompare. So usichanganye, lakini kumbuka hii yote ni wavelength. Sema tu hii ni an extra wavelength ambayo ilikuwepo in that motion, in that wave, lakini yenye x ndio tutaicompare na x yetu, tutapata wavelength ambayo tutatumia wavelength, tutatumia na hiyo frequency ambayo tunayo, tutapata speed yetu ya wave. Vertical displacement of the string at time t is equal to 0 na x ikiwa ni 1 meter, so we can put t is equal to 0, x ikiwa 1 meter. It's just a straightforward thing. Tunatafuta value ya y ambayo ndio hiyo s. We have that t ikiwa 0 hapa, ina maana inakufa. So ndani inabaki sign ya negative 3 pi x tumepewa 1 plus pi over 4. You can solve that sign na multiply na hii to get your answer. What is the wavelength and frequency of the wave? Tumesha zitafuta wakati tunatafuta speed hapo. Maximum magnitude of the transverse speed of the string. Hii ina require ile shule ya nini? Shule ya simple harmonic motion. Okay? Simple harmonic motion. We know that for simple harmonic motion y ni sawa na w square root ya a squared minus x squared. So speed is maximum. Where is speed maximum? It is maximum kwenye origin. Okay, it is maximum kwenye origin. Speed is usually maximum kwenye origin. So at point x is equal to 0 ndio tunapata maximum speed. So x ikiwa is equal to 0, so we have square root ya a square imebaki ndani, so we have w times a. Hii ndio maximum speed of simple harmonic motion ambao ni kama wave tu. So w tunayo, amplitude tunayo 0.35. From there we can solve and get our answer for maximum magnitude. For minimum speed, we know it is usually minimum speed is usually at point a is equal to x. So manake these cancels na baki w peke yake, hiyo ndio inakuwa ni minimum speed. So it's just issue ya recall simple harmonic motion. If you can recall your simple harmonic motion, then it's fine. So that's the beauty of physics, where two topics combined form one question. Ingawa point yangu ya concern hapa ni wewe ujue namna ya kufanya hivi vingine, frequencies, amplitude, wavelength na nini. Hiyo harmonic, knowing it ni added advantage. Lakini for now make sure unaelewa jinsi ya kupata wavelength, jinsi ya kupata frequency, either by comparison au kutumia concepts ku manipulate hizi formula na kuweza kupata solutions zetu. So in the next question, you have a string shown in that figure here. It is driven at a frequency of 5 Hz. The amplitude umepewa, the wave speed umepewa. Furthermore, the wave is such a way that y is equal to 0 at x is equal to 0. It means kwenye origin ndio inapoanzia. Determine the angular frequency. Angular frequency is sawa na 2 pi f. It's straightforward. Una value ya frequency umepewa, so you put 2 pi times the frequency umepewa, unapata angular frequency. The wave number, which is that k which I was speaking about, kwenye ile phase angle yetu tulisema phase angle ni 2 pi x over wavelength. So this k is what we call the wave number. This k is what we call the wave number. So if you cancel x na x, unapata k ni sawa na 2 pi over wavelength. So the wave number, how to get the wavelength? It's just simple. You have the velocity, you have the frequency, you can get the wavelength. You have the velocity, you have the frequency, you can get the wavelength. From here, wavelength ni sawa na velocity divided by frequency. Sawa na velocity divided by the frequency. So you can get the wavelength. You put in here 2 pi over that wavelength, unapata ni sawa na k, which is the wave number. Again, write the expression. Is just simple. You have the general equation given by that. We have y is equal to a. We have the amplitude, which is 12 centimeters. Converting it into meters, unapata 0.12. Unaweka hapo sin w, tumeshaambiwa tafuta angular frequency, unaweka hapo t minus the wave number ambayo tumesha calculate 2 pi over wavelength ambayo tulipata times x, unapata equation yako. Calculate the maximum transverse speed na maximum transverse acceleration, or we know this again is in harmonic motion. So maximum v maximum tunapewa kwa wa na a maximum tunapewa kwa a amplitude times w squared. Okay, amplitude times w squared. So we know that kutokana na simple harmonic motion knowledge. If you can recall, nimesema ni added advantage, but my point of concern ni kujua jinsi ya kufanya hivi hapa. I remind you kwamba part ya kwanza ya simple harmonic motion exactly ina the same features kama hivi ambavyo tunasoma, ndio maana unaona vina kwa combined somehow na simple harmonic motion kama namna hiyo. So in the last part we have another question ambao similarly kama ila juu, where we have to write an expression. Tumepewa values mbalimbali kama amplitude ni 8 centimeters, na wavelength umepewa na frequency umepewa. You have everything, so write the expression. Okay, the first question was write an expression. Okay, ni kama hapa tu, we have amplitude tumepewa ni 8 cm ambao ni 0.08 meters. We have the angular velocity ambayo tunaweza tukapata kwa kutumia 2 pi f, tunaweza tukapata frequency tumepewa, so we put it hapo. And we have the 2 pi over wavelength tumepewa, so we can write the equation just like that. The second part B tells us that write the expression of y as a function of x and t for the wave in part A, assuming that y x, 0 is equal to 0 at the point x 10 centimeters. So what does that mean? It means that the value of y is 0. The value of y is 0 at a point where x is equal to 10 centimeters. So we know the general equation kama nilivyoandika hapo. So tumeshapewa value ya ya y ni 0, value ya y ni 0, na tumepewa value ya x, na tumepewa value ya x ambayo ni 10 or 0.1 meters. So if we put in the numbers, we can. So with this we are done here. As for this question, you can try again on your own, marudio tu ya parts ambazo tumeshafanya nyuma. So by now I believe you are competent, so you can do this on your own. I don't believe kama linaweza lika kushinda kufanya that part.